got to start the record again also. Okay. Find the value of x.
For 11. Okay, so 1, 2, 3, 4, 5. Yeah, 5.
So what's the sum of the interior angles?
540 degrees.
Okay. What's the sum of the four angles that you see there?
That would be 423.
Okay. You used a calculator? I'm trusting you?
Yeah.
Because I didn't. I'm just going to assume that you got it right. So subtracting those gives you an angle of x has to be equal to 117. Now, it's not a bad idea to check, make sure, yeah, that looks like an obtuse angle. In other words, if that looked like an acute angle, there might be something wrong here. But it's always good to visually check your information. How am I going to solve 12? How many sides is 12?
12 is 1, 2, 3, 4, 6 sides.
Okay, so what's the angle sum be?
720.
Okay, and we have all the angles except one. That's 90 there.
Yeah.
So add those 5 angles, subtract from 720, and you have your answer.
They go up to 480. Well, 1 second. 570, sorry.
You added the 90 also?
Yep.
Okay. And that is 150 for x, and that looks about right. Okay. So these are relatively simple. 13, you see how you're going to do that?
Yeah. Yeah.
You're going to count the sides up, figure out what the sum of the angles equals, and the equation is going to be 3x plus the sum of those 6 numbers you see equals whatever that number is supposed to be. Okay? Let's look at 14, 15, and 16 because they deal with exterior angles. So what equation can I write on 14?
360 divided by n.
On 14?
Yeah.
This one here?
I think so.
Okay. What's the sum of the exterior angles? It's always 360, no matter how many sides.
Okay.
The sum of that plus that plus that plus that has to equal 360.
Okay.
Okay, so what's the sum of those 3 numbers?
249.
So 360 minus 249, 111, and again, that looks like about a 111 degree angle. Okay, so we're going to do 15, exactly the same, only this time they give us 3 exterior angles and 2 variables. So what's the equation that I'm going to end up with on 15? Use your calculator. 85 and 77 is what? 162?
Yeah.
So what's the equation got to be?
It'd be 18 divided by 3 to find the x's.
Okay, let's start from the beginning. Because when you jump in the middle, I'm not sure what you've done. So starting with x plus 2x plus, what was the sum of those 3? 162?
Yeah.
That has to equal 360.
Yeah.
That's what I mean by start at the beginning. And
Okay.
then you jump to the end, which is okay. So what is this? 198. So x equals 63.
Yeah.
And that looks right also. 16. They don't even increase the difficulty of these. What's the equation on 16 going to be, conceptually?
2x plus however many other degrees there are equals 360.
That's it. This is one of the easier sessions you've had because it really only requires those two formulas. 22 might be a little interesting. Was there any other one that they asked you to do? 18 maybe?
Yeah.
Okay. Measures of the interior angles of a quadrilateral are x2, x3, x, and 4x. What's the measure of the largest interior angle? So always try, when you're trying to solve these, always look to set up an equation. It's always the goal is to what equation can we write and then solve it. That's why algebra is 50% of geometry, because you always end up with an equation that you then have to solve. First of all, what are the measure of the interior angles of a quadrilateral going to be?
That would be 360.
Okay. So what equation can I write?
10x equals 360.
So what is the measurement of the largest angle?
36.
No. That's the measurement of x.
Okay, so
it's a little bit of a trick question. They didn't ask you to solve for x. They want to know what 4x is.
So that'd be 144 then.
Right. Right. Let's look at this one here. Similar figures. Have you gotten to similar triangles yet? You must have.
I'm not sure.
Really? Okay. Well, similarity is not congruency, but if I'm talking triangles, obviously there's the congruent triangle, but any triangle that has those same three angles is similar. Okay? And that's pretty much the definition of similarity. And it doesn't have to be just between triangles. You'll notice that this is a four-sided figure. Actually, the total thing is a hexagon. And they're saying this hexagon is similar to this hexagon, which means every angle is the same. R is the same as J, S is the same as K, even if they weren't regular. In fact, these aren't said to be regular. And once we know they're similar, what we know is that each corresponding sides are proportional. In other words, what was that? Corresponding parts of congruent triangles are congruent. Well, that is true whether they're triangles, rectangles, five-sided figures, whatever. Corresponding parts are similar. This actually should say proportion. Corresponding parts of I'm going to end up with a completely different anagram here. It's corresponding parts of similar polygons are proportional. And that's why they don't have one, but that's the essence of it. And so if they tell me that ST is 6 and KL is 10, that tells me that that ratio is 10 to 6. Okay? And they tell me RU is 12. Well, that's clearly the smaller number. So JM is what I need to solve for.
Okay.
Just set it up as a ratio problem. The same way you would solve similar triangle. You're going to get a lot of these with triangles. where you are given two similar triangles and they give you the dimensions on one and you have to come up with the dimensions on the other. And they're all ratio problems. Find the corresponding sides, figure out what their ratio is, and then come up with whatever. In other words, clearly JM here has to be 20, which is the same 10 to 6 ratio. Okay?
Yeah.
All right, let's see. We got a few minutes left here. Find the measure of interior and exterior angle. Yeah, let's do 19, 20, and 21, or at least one of them. What's the measure of the interior angles on a regular pentagon? Pentagon is how many sides?
5. So it's 540.
Okay. What is irregular means 5 equal angles, 5 equal sides.
Okay.
So what's each? It says find the measures of an interior angle. So what would it be?
So that'd just be 540 divided by 5, right?
Uh-huh. So every interior angle on a regular pentagon is 108 degrees.
Okay.
What's the measure of an exterior angle?
The exterior angle would be 360 divided by 5.
Good. Which is what, 72 degrees? Okay.
Yeah.
And that's all you really have to do here. How about an 18agon? You might need your calculator, but it's all right. So the formula that you could go straight to, that's the total number of angles, right?
Yeah.
And you're always dividing by the number of sides. So that formula actually gives you the measurement of one interior angle on a regular polygon.
Okay.
Not that you really need to memorize this as a formula, because you're always going to do this. In other words, you're always going to come up with that, and then you're going to divide by 18, right?
Yeah.
All right. And the measurement on an exterior angle.
For the 18agon?
Yeah.
All right. So I got 2,880 for the top number,
Okay.
and then divide that by 18.
Okay. That's going to give us the interior, right?
Yeah, so that's 160.
Okay. What's the measurement of the exteriors? There's the hard way to get it and the easy way to get it.
That's 20.
Uh-huh. Did you do it the hard way or the easy way?
I just divided 360 by n.
Right, but it's also whatever is supplementary to that interior angle. Notice that the interior angles are always made up. In other words, there's the interior angle, there's the exterior angle, they're always supplementary. So you could have taken your answer of 160 and subtracted it from 180.
Or just, yeah.
And
Okay.
each of those would be 20 degrees.
Okay.
And as far as that exterior angle goes, sometimes it's confusing if you go both ways. In other words, pick a direction and go one direction only.
Okay.
I start drawing exterior angles that way. Is that the exterior angle or is that the exterior angle? You know, it's hard to know.
Yeah.
How you construct it, like I said, I started here and extend. And now I know what all my exterior angles are. That one, and so forth and so on. They
All
didn't
right.
each come out to be 20 because I didn't draw a regular 18 agon. What's an infinite agon?
I don't know. We haven't talked about it.
No, I just made it up, but I wanted to know whether you're thinking about it. What would it be?
Would it not have any sides?
Huh?
I don't think it'd have any sides.
Exactly. So what is it called?
Nothing? A circle.
A circle.
Okay.
Exactly. In other words, if you had a 90 agon, or a 90 gon, it would look close to a circle. If you backed up far enough, it would look like a circle. If you had a 1,000 agon, it would even look closer to a circle. That's why I say an infinite gon is a circle.
Okay.
Now, that's not a true mathematical term, by the way. I think you knew that already, though.
Yeah.
All right. Any other questions, Mark?
No.
Did we cover everything we needed to cover? Was there any on here that we didn't cover?
No, I don't think so.
We didn't look at these two, but I think most of this stuff is pretty easy once you know those two formulas.
Yeah.
All right. I will let you go and talk to you on Thursday.
Okay, 1 second.
Uh-huh.
Can you send us an invoice?
What's that?
How much we owe him? I need to pay him.
Okay.
Yeah.
Do you want his PayPal too?
Do you have, I might have gotten this already from you, but in case I didn't, can you give me your email address and I'll send you an invoice?
Okay.
What is it?
It's GGD. It's the letter G, the letter D as in David, INCO at Comcast.net.
Okay. And that's where you want me to send it?
Thank you, David. I'm sorry I haven't paid you yet for
Oh,
this.
no problem. I hadn't sent an invoice out, so I've been lazy in my accounting work, but I'll get you an invoice out by tomorrow and get it out.
Okay. And I hate owing people money. So
Oh, that's okay.
and you've been on my mind every week.
Oh,
So
well,
yeah.
like I said, that's my fault, not yours.
No.
So
Well, thank you. And he's doing well. I mean,
good.
He's seen improvement. So thank you,
Good.
David,
Great.
for your help.
Great.
Really.
Love to
I
hear it always.
appreciate it.
Okay.
Okay. Have a good night.
Okay. Talk to you later. Bye-bye.